A colossal Atlas V rocket, souped up with every booster possible, roared to life. All that power to accelerate a 1,000-pound space probe to speeds fast enough to break the surly bonds of Earth and the Sun, because this was no ordinary journey. New Horizons was headed to our 9th planet, the traditional last one. The United States had been the first to get probes to every other planet. It was time to bag Pluto. Even with the penetrating eye of Hubble Space Telescope, this was the best image we had of Pluto in the 21st century. It was a complete mystery.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
Just 8 months into the journey, she took a hit. Not a space hit, but a blast of indignity from back home.
Those who are in favor of Resolution 6A, which introduces this new category of trans-Neptunian objects with Pluto as a prototype.
Her destination, Pluto, got demoted from real planet to dwarf planet at a meeting of the International Astronomical Union. It turned out that Pluto was just one of many chunks of ice and rock way out there in a region called the Kuiper Belt, beyond the traditional solar system's edge. Pluto wasn't even the largest dwarf planet. The announcement created an uproar, to say the least. People back on Earth were heartbroken and furious. New Horizons was oblivious, fortunately, snoozing out where nobody can hear you snore. "13 months into the journey, her handlers shook her awake for a very early dress rehearsal at Jupiter. At the giant planet, she got to try out her 7 fancy science instruments. From January through June 2007, these instruments collected more than 700 separate observations of the Jovian system, capturing things like lightning near the planet's poles and spectacular volcanic eruptions on Jupiter's very active moon, Io. A big bonus of the Jupiter flyby? The giant planet's gravity picked up little New Horizons and flung her away so fast it shaved 3 years off the journey to Pluto. Now came 8 years of mostly napping, with dutiful weekly calls home to reassure anxious Earthlings. As New Horizons was finally closing in on Pluto, those Earthlings realized they had frightening new reasons to be anxious. Pluto's moons began to multiply beyond its giant companion Charon and 2 other known satellites. The discoveries of tiny Kerberos and Styx meant that New Horizons could have been headed into a minefield. Such small moons don't even have enough gravity to make space debris stick to them. So there could be a lot of little junk in orbit around Pluto.
Here's this grain of rice. In fact, if I I just broke off most of it. Can you still see that tiny little piece there? This is still bigger than what it would take to destroy the spacecraft. It's going to be enough to end the mission.
And at 10 times the speed of the fastest bullet, there'd be no time to maneuver around even things they could see. After days of observations and computer modeling, they came up with what they felt confident was a safe path through the Plutonian system.
Well, we're moving really, really fast, and we can't just dodge things. So we kind of have to take our best shot.
You know, it's like any other space project where that you're going to some place that you've never been before. You really are in the discovery mode. So the way you deal with that is you have plans and you have backups to your plans and you have backups to your backup plans. With a little bit of luck, you really have covered all the bases.
All right, so you go. We're all go. You go, man.
Everyone heaved a sigh of relief. Too soon. Their real worries were just beginning. New Horizons stopped speaking to them. Could she have hit some space debris after all? Was the mission a complete loss? With a round-trip communication time to Pluto of 9 hours, there would be no real-time help for the little probe.
Here we had flown more than 3,000 days to reach our target at the far frontier of the solar system. Just as we were uploading the final instructions for the spacecraft to carry out the flyby, we lost contact. That had never happened before in the entire flight.
The engineering team gathered at APL and quickly realized that if the probe was on the right trajectory and experiencing a computer glitch instead of a catastrophic failure, she'd reboot and check in about 90 minutes.
On the Salem Pluto 1, we have carrier Muck waiting on telemetry. Okay.
Right on time, New Horizons phoned home. But she was in backup mode on a very slow connection. Apparently, they had asked too much of the primary computers while uploading the flyby instructions. They faced a near impossible task. Weeks worth of work to cram into days. This flyby was going to be the definition of a nail-biter.
We reestablished contact. And then we had an enormous job in front of us. The job of first getting the spacecraft back off of emergency low bitrate communications to where it could speak to us at high speed. Remember, that's a 9-hour round-trip light time, so just sending those commands took a third of the day. But the clock is ticking. There's only 3 days until the flyby begins. 6 months of work down the drain. We had to replace all of the flight plans, all of the guidance files, all the navigation files, all the pointing files, and many more, and get them all in place in 3 days.
So much for anybody's 4th of July celebrations. Everyone just dropped everything and headed into the applied physics lab.
The engineering and the operations team literally came in on July 4th, the last day they could be with their families before the flyby. People showed up in all states of dress. They came from picnics, they came from July 4th parties, and they never left. For 3 days, just like in that Tom Hanks movie, Apollo 13, they were sleeping on desks, people were sleeping under desks, people were sleeping in chairs, living on 3-4 hours a night, because they knew what was at stake. One spacecraft, barely 10 days out from Pluto with a one-shot encounter.
It took 2 days to coax the main computer back online and reload her with hundreds of thousands of commands necessary to get her through the flyby.
And they did it all, and they did it flawlessly, and they are the unsung heroes of the Pluto encounter. They made it work.
With just days to spare, New Horizons seemed completely healthy and ready for her historic encounter.
I mean, what is that saying? Defeat is not an option.
The 7-day flyby began on July 14th. On her own, at the edge of the solar system, New Horizons conducted hundreds of observations on 6 targets: Pluto and her 5 moons. Her last image before closest approach held the scientists and the world in awe. Tiny Pluto was a magically diverse world with a big, big heart. At closest approach, she passed a mere 7,700 miles above Pluto's surface, moving so quickly that she swept across the whole surface heart included, in 3 minutes. But it would be more than 4 hours until the team would know if the mission had been completely successful, and that their spacecraft was healthy and hanging on to her motherlode of groundbreaking science.
On the Deep Space Network.
In lock on symbols.
So that's the first step. You're getting data?
Okay, copy that. We're in lock with telemetry with the spacecraft. Go ahead, CNDH.
CNDH reports nominal status. Our SSR pointers are where we expect them to be, which means we've recorded the expected amount of data.
Copy that. Looks like we have a good data record. We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
On flyby day, the team got its first high-resolution glimpse at the geology of Pluto's surface.
And I remember looking at that and thinking, what a stunning world. Look at this. There are polar caps and canyons and dense crater fields and vast glacier fields and mountain ranges, some with snow caps, some made of one material, some made of another. Many types of evidence for tectonic activity on the surface, and just taking in the totality of it and thinking, who knew there was so much in this little package? That Pluto would be so nuanced and so complex, and that its history was bound to be so difficult to unravel. And it really set me back, because I'd waited to see that image for over 20 years, and I'd expected it would be good. But I have to say, I don't think anybody on our science team, certainly not myself, expected it to be that good.
It is simply amazing that we can send ones and zeros across almost 3 billion miles, and we're there at the right time to capture that information. I mean, this is science at work. I mean, it's just fantastic.
But with communication speeds equal to roughly that of slow 1990s dial-up internet, it'll take 16 months for the data to reach its anxious parents back home.
So our PI always likes to say, this is the Christmas that never stops giving. You're going to get a present every single day for the next 16 months.
Some of the Christmas presents from the Plutonian system are simply mind-blowing. The big moon, Charon, has an enormous gash right around its midriff, much longer and deeper than even our Grand Canyon. Charon was almost certainly formed in an enormous collision between Pluto and another large body. And while the remnants of the collision were still hot, Charon had a heart of liquid water that slowly froze, expanded, and cracked the moon right across its belly early in its history. At least Charon seems to have obeyed the laws of physics and quickly run out of heat out here so far from the sun. But only heat can explain Pluto's dazzling surface.
And before the Pluto flyby, it was widely expected that small planets should cool off during those billions of years and their geologic engine would run out. We would only find ancient terrains on the surface. Instead, we found terrains on Pluto that have been created throughout the 4 billion years. Vast terrains, millions of square kilometers of terrain that have been created in the recent geologic past. It's just amazing.
Of course, the most amazing and seriously active feature is Pluto's big, bright heart, called Tombaugh Regio, named after Pluto's discoverer, Clyde Tombaugh. The mysterious left lobe of that heart, dubbed Sputnik Planitia, is a giant ice field hundreds of miles across, ringed by 15,000-foot mountains. Scientists think it's a huge impact basin that filled with nitrogen snow and ice falling out of the atmosphere over time. And that ice field seems to be boiling in incredibly slow motion. Those oval shapes are like bubbles overturning. What this means is there has to be a heat source driving that convection, renewing the surface constantly, which is why it's so smooth. Any impact craters are continually being erased. These are actually glaciers of water ice floating on a denser nitrogen ice. Mountains as large as the Rockies with methane snowcaps. Giant ice volcanoes that were recently active. And ancient cratered areas 4 billion years old, right next to the very young, geologically active parts. Perhaps most exciting of all, Pluto's giving scientists all kinds of reasons to believe that there's a large liquid ocean under the surface, giving off heat as it freezes. And that raises the possibility of life at the far edge of the solar system.
If there's a potential for astrobiology at Pluto, it's probably deep in the interior, where there's very good but still circumstantial evidence that Pluto's water ice crust far below the surface actually liquefies to become a perched ocean of liquid water and a warmer zone quite deep in Pluto's interior.
The possibility of life may be an incredibly long shot at this time. And even if it's not a full-fledged planet in the eyes of some, it certainly has become a dazzling and puzzling world in its own right.
Regardless of what you think that Pluto's status is, I think you can kind of check off the box of, well, we've flown by all the planets.
Pluto is now far in New Horizons' rearview mirror, along with its beautiful baby blue atmosphere. And the fully functioning craft is headed into that Kuiper Belt with new marching orders. She's been retargeted toward a whisper-close flyby of a Kuiper Belt object in 2019.
It doesn't have a name yet. It's called 2014 MU69 for now. That's kind of a license plate. And we're homing in on it. We've already fired our engines to take us there for a rendezvous on January the 1st, 2019, in which we'll swoop right down on the deck to see its geology, its surface composition, to study any satellites it may have, to look for an atmosphere or a cometary coma that it might have. And we'll collect almost as much data as we did at Pluto, and then we'll download all that to Earth. So from 2016 to 2021, we're going to be very busy with New Horizons. It's the only mission planned to travel through the Kuiper Belt, and we're going to milk that for everything we can possibly learn about the Kuiper Belt, because who knows when a subsequent mission will be able to come back.
The Kuiper Belt extends billions of miles beyond Pluto, once considered the end of the solar system, and contains hundreds of thousands of objects, not to mention hundreds of dwarf planets like Pluto.
I think New Horizons really exceeded our expectations. It taught us that small planets can be as complex as larger planets. Pluto's every bit as complex as Mars, some would say as complex geologically as the Earth, and that was really unexpected. And it's telling us that we should do more exploration of small planets in the Kuiper Belt. Also, at the very top of the list, we learned that small planets can be active even at billions of years after their formation.
New Horizons is about to introduce us to a whole new realm of undiscovered worlds in our galactic neighborhood, and her parents couldn't be prouder.
And it's also true that for our generation, which is the second generation of planetary scientists, really the whole solar system had been mopped up by our parents' generation. They'd done it all from Mercury to Neptune. And this is kind of the last train to Clarksville. So it was very special. It's a dream come true to get to work on something as unique as the first mission to the last planet.